This is 5.6, and we're going to take what we've learned and do some exponential and log equations. We're not really learning too much more except how to put it all into play. So if we started out with 4e to the x equals 5, you want to isolate the exponential expression. That means, is 4 being raised to x? No, it's not. So we'll divide both sides by 4. Now we have e to the x equals 5 over 4. Take the ln both sides. Ln of e to the x equals ln 5/4. Remember the rule, ln of e to the x equals x. So this expression simplifies to just x equals ln 5 over 4. If they want approximate, then you do that on the calculator and get 0.2213. So that's if the base is e. Now, for this one, there's another rule. ln of a to the x, that's for every base except e. All that lets you do is bring that power to the front. Remember that power rule. So we have 4 to the x minus 1 equals 3 to the 2x. We're going to still take the ln of both sides. And then we've got to bring the powers to the front. So x minus 1 comes to the front. 2x comes to the front. So for this one, think about that this is a number. We need to distribute that number. So we have x ln 4 minus 1 ln 4 equals 2x ln 3. And just like regular equations, we got to get the x's on one side and the numbers on the other. So we're going to subtract this x ln 4 over to here. I'm showing that right here. We did both places. So it's gone here. We have negative ln 4 equals 2x ln 3 minus x ln 4. Well, we need to get just x there. So we're going to factor x out. When I take x out, I'm left with 2 ln 3. And over here, I've got just ln 4. Now I need to divide this whole thing, which is just a big number. Not a big number, but it's a number. I'm going to divide it on both sides. That leaves x on the right and all of this on the left. And when you do this in the calculator, be sure you do all the parentheses just like I've done, because you have to have the whole denominator in a set of parentheses. And it would be negative 1.710. All right? And then that's exponential. Now, logarithmic, we've talked about this a little bit. You want to change to exponential form. So if you have log 2x plus 1 equals 2, it's an understood base of 10. We'll write that in. This is the argument, this is the base, this is the exponent. So 10 raised to the second power equals the argument. 10 to the second is 100. Then you've just got a plain equation to solve. Subtract 1, divide by 2. That's 99 over 2, or 49.5. What if we've got we got logs on both sides? Well, we still have to get it to where we can change it to exponential. So let's get the logs together. We're going to add this log base 2 of x over here. So I've got these two equal 2. And that's an addition. So we're going to change that into a product. Log base 2 of 4x times x equals 2. That becomes 4x squared. Now I can change it to exponential. 2 to the second power equals 4x squared. 4 equals 4x squared. Now divide by 4 and you've got x squared is 1. Take the square root of both sides and you have plus or minus 1. So, log functions, change them to exponential. Exponential, you have two rules at your disposal. ln of e to the x equals x, or ln of a to the x equals x ln a. So let's go see what our problems look like. All right, let f of x and g of x be functions below. Answer the following questions. Use the graph to solve the equation. Where is f of x equal to g of x? Well, if you're just looking at the graph, And I can't make that little thing bigger, but it looks like they intersect at x equals 5. And then if you solve that symbolically, we can take ln x equals 1.6, and we can exponentiate is what happens. We're going to take the base of e to the ln x equals e to the 1.6. That, just like ln of e to the x, this becomes x as well. And we have e to the 1.6. You could do that in your calculator, and you get 4.953. Number 2, 3e to the x equals 16. So let's work that here. We want to isolate, so we're going to divide by 3. E to the x equals 16/3. Take ln of both sides. That leaves just x here, and we've got ln of 16 over 3. Round to 4 places on your calculator, and you should get that. All right, 4 times 3 to the x minus 3 plus 2 equals 110. All right, so let's subtract this 2 over here. Now we've got 108. Let's divide by 4. That leaves 27. So now we've got 3 to the x minus 3 equals 27. And we should recognize we can write 27 as 3 cubed. And so we have x minus 3 equals 3. So x is 6. Anytime you can make both bases be the same, that's the way to go. All right, number 4, solve the exponential equation. Subtract 1. So we subtract 1. We've got 2 times 1.17 to the x equals 15. Divide by 2. So we're isolating this. Then you take ln of both sides. So this is not e. So all that can happen is the x comes to the front. Then if we're trying to isolate x, we can divide both sides by this number. So we have x equals ln of 15 halves over ln of 1.17. Should get this on the calculator. Number 5, 1.3 e to the negative 1.4x equals 1. Divide by the 1.3. Isolate that e. Then take ln of both sides. We got that, and that's going to just leave negative 1.4x here. And divide by negative 1.4. So now you're ready to put this in your calculator to get your final answer. Number 6. Okay, we've got this equation. So I wrote it here. We're going to subtract 2. That gives us 13. Divide by 4. We got 13 over 4. Take the ln of both sides. Then the x comes to the front, because that's what we can do with that when it's not e. Divide by ln 1.09. So here's what you'll put in the calculator and get your final answer. Number 7. The bases are the same, so we can just eliminate the bases, and we have 4x equals 1 minus 2x. Add 2x over there. You got 6x equals 1. X is 1/6. Same thing for number 8. Those are the same bases. So we can say x squared is equal to 3x minus 2. Get everything on the left equaling 0. We can factor this to x minus 2 and x minus 1. That gives us x equals 2, x equals 1. On this one, solve the exponential equation. So on this one, the left side domain is always positive. So it's never going to be negative, and we're saying it's equal to a negative number. And so there is no solution. It's never going to happen. All right, number 10. We're getting toward the end. So 3 to the x plus 4 equals 8 to the x. ln of both sides. Remember, we're going to distribute. Well, this power is going to come to the front first. Then we'll distribute. So we have x ln 3 plus 4 ln 3 equals x ln 8. I'm going to subtract this on both sides, so it goes over here, it's gone here. I'm going to factor out x, which leaves me ln 8 minus ln 3. I'm going to divide by that whole thing so that this is my final answer. If you do it in the calculator, you get 4.480. 11 e to the x equals 3 to the x plus 3. So we've got two different kinds of bases. Take the ln of both sides. Let's see what we can do. Well, when we do it here, we're left with x. Here, the x plus 3 can come to the front, and then we'll distribute, and we have x ln 3 plus 3 ln 3. All of that equals x. Well, the x terms got to get together over here, so subtract this. So that's where I am here. I'm going to factor x out here, and that leaves 1 minus ln 3 equals 3 ln 3. Divide both sides by this, and now you have your x equals, and it should be negative 33.42. Okay, number 12 should be our last one. 8 to the x minus 3 equals 64. This one's much easier. 64 could be a power of 8, 8 squared. When you get the bases the same, then you can just set the exponents equal. X minus 3 equals 2, so x equals 5. And I'm not sure why they did this, but they made you put it down with 5.000 as well. So I think that's it. Exponential equations. That should get you going on that.